Hi guys, so we are going to solve the problem page 667 regarding the section 11.4, and we are going to start with the problem number 6, which is related to the counting principle. And the counting principle is very simple. It's about when you have one experiment that can be performed in m distinct ways, and you have a second experiment that can be performed in n distinct ways, then the two experiments in that specific order can be performed in m multiplied by n distinct ways. So in this problem, you have 365 days, and you have to pick up one of these days, out of the 365, and then you put it back, which is with replacement, and you selection another day. For both selection, you have 365 choices. And so the number of possible outcomes is going to be, based on the counting principle, 365 multiplied by 365. And the answer is going to be 133,225. Now, without replacement, and I should have wrote right here, without replacement, for the first selection, you still have 365 days, but because you don't put that day back into your number of days that you can choose, now for the second selection, you have 364 days. And so the number of possible outcomes is going to be 365 multiplied by 364. And so the answer will be 132,860. All right, so let's try to do problem number 7, which is based on the same idea. So on this problem number 7, you have a bag containing 5 batteries, all the same size, and equally likely to be selected. Each battery is a different brand. If you select 3 batteries at random, use the counting principle to determine how many points will be in a sample space if the batteries are selected. So we have 5 batteries, and they are all different brands, so I'm going to use a different color representing the battery, and I'd like to define how many points will be the sample space if the battery are selected. And I would like to remind you, I'm sorry, that if you select 3 batteries at random, so and for the question A is a with replacement. So every time I take 1 battery, I put it back, take 1 battery, I put it back, and I take 1 battery and I put it back. So every time I'm going to choose 1 battery out of the bag, I put that battery back in my bag. So for each battery, I will have 5 choices. Therefore, I end up to have 5 multiplied by 5 multiplied by 5 equal 125 points that is defined in the sample space if my battery are selected with replacement. Now, without replacement, what is happening? That was for A. Without replacement, I still have my battery, and I'm going to choose the same color. So for my first choice, red and purple and light blue. For my first choice, I will have 5 batteries in my bag, but I'm not replacing. And so if there is no replacement on my second choice, let's imagine that I pick the blue one. For my second choice, I'm going to have only 4 choices, right? And for my third choice, I'm going to have only 3 choices. And let's imagine I took the magenta. That's the right way to pronounce that word. And so basically, without replacement, I end up to be with a 5, 4, and 3. And the answer is going to be 60. So I'll let you do problem number 8 on your own, and let's try to jump on the problem number 9. On this problem number 9, determine the number of sample points in the sample space, and you have two cones are tossed. So I have 2 cones. 2 cones are tossed. And so if I look at the cones, determine the number of sample point in the space. So each cone, you have head and tail, and so you have for each cone 2, and because you have 2 cones, 2 multiplied by 2, base 2 coming from head and tail. So the number of sample points in the sample space is going to be 4. Now, how can I check on that? Well, if I take the cone number 1, okay, I can have the head, I can have the tail, and if I look at the cone number 2, I will have a head, and I will have a tail. All right, guys, so of course, because we have 2 cones, we will have the possibility to have head, tail, tail, or tail. In the C, determine the probability that there is no tail or toast. So how do we calculate the probability? I would like to remind you that the probability of an event is defined as the number of outcomes favorable to the event divided by the total number of outcomes. So when I'm calculating the probability that there is no tail or toast, I can, let me just recap. We have head, tail, head, but also tail, where the probability there is no head, no tail, no tail, it's only 1 out of 4. 1 divided by 4. Now if I look at D, which is exactly 1 tail is toast, for 1 tail toast, I can see right there is 2. The probability to have one tail toast will be 2 divided by 4, which is at the end 1/2. For E, 2 tail are toast, so the probability that we have 2 tail is going to be 1 divided by 4. And if I look at the last one, which is the probability at least 1 tail is toast, so at least is very important, 1 tail. Well, when I'm going to look at it, I can see that there is 1, and at least 1 tail, so I need to count also this one. And so the answer is going to be 3 out of 4. 3 divided by 4. All right. Let's move on to the problem number 11. On this problem number 11, a card box contains 3 cards. There is sun, another card is a question mark, and a third card is an apple. So I got a card with a sun, I got a card with a question mark, and I got a card with an apple. 2 cards are selected at random with replacement. So 2 cards selected at random with replacement, with meaning that I will put them back. And the question is, determine the number of sample point in the sample space. So what is happening is I'm going to take one card. For the first card, I will have 3 choices. But because I take my first card and I put it back, for the second card, I will also have 3 choices. Therefore, using the counting principle, I'm going to have 3 multiplied by 3 equal 9, and that would be the number of points in the sample space. Let's try to do the diagram, the tree diagram, and we will list the sample space. All right, so guys, this is the tree diagram. On the first card, if I have a sun, on the second card, I can have a sun, I can have a question mark, or I can have an apple. If my first card is a question mark, I can have a sun, question mark, or an apple for my second card. And if my third card is an apple, I can have a sun, a question mark, or an apple for the second card. Therefore, if I need to list the sample space, basically what I have, it could be a sun, question mark, sun, apple, but it could be also question mark, sun, question mark, or question mark, apple, or it could be apple, sun, apple, question mark, and apple, and that corresponds to the number of sample points, the number of sample points in the sample space, which is 9. Determine the probability. So now we have determine the probability that 2 cards containing apple are selected. So the probability that 2 cards will be apple. When I look at my tree diagram, how many times do I have 2 cards with apple? Only 1 time. Out of how many? 1 out of 9. When I look at the question D, so the question D is a card containing a sun, then a card containing a question mark, and there is only 1 out of 9 where you have the probability to have a sun and then a question mark, because the most important part is and then. Because you have a and then, that means the first card has to be the sun. Now, on the question E, we have at least 1 card that contains an apple is selected. So the probability to have an apple, at least. So when I look at my sample, I have at least 1 card apple, let me use another one. So 1, 2, 3, 4, and 5 again. So the answer is going to be 5 out of 9. So my advice would be this. You must be very careful on how you are reading your questions, because depending on how you are reading your question, you are going to make a mistake or not. The first example will be with the question C. The question D, because you could have thought, oh, it could be also a question and a sun. No, they said sun, then the question. So please be very careful, and everything will be all right.